Okay, good evening, everybody. We're looking at a two-part video series all on our new chapter topic, the absolute value. Okay, so hopefully this will get you in tune with the concept so that when you come in tomorrow's class, you'll be completely ready to do some new stuff with this. So for some of you, you've seen this thing before. Maybe it won't be talked about in the same way that I will, but you probably have an inkling of what the absolute value is. It's not a really difficult concept. It should be pretty simple for most of you guys. So let's just go through it and see where we go. Okay, so chapter 7, have your notes out. You're taking notes on this one, guys. Absolute value is nothing more than asking ourselves, let's see if I should just write it down. Okay, absolute value. The absolute value is how far away from zero am I? So, for example, if I looked at the number 4 and I want to know what the absolute value of 4 was, so here I am, 4, absolute value 4. And notice what I'm writing here. There's actually a bit of symbology that I'm using here, a new way of writing things. So when I say absolute value, I put these two fairly long, straight, vertical lines on either side of the thing I'm trying to give an absolute value to. So this is how you write it, two big lines. So what is 4? In other words, how far away from 0 is 4? That's simple. It's 4. It's 4. It's 4 away. So when I deal with some positive numbers and I want to find the absolute value, nothing really changes. The absolute value of 4 is 4. The only time it gets a little different is if I say, well, what is the absolute value of negative 2? How far away from 0 is negative 2? And I go, well, it's 2 away. So therefore, the answer is 2. And you might say, well, Mr. Gale, that's nothing more than just taking the negative off. Isn't that all you're doing? You're making anything inside positive? Yes. Yes, it is. But it's a little more complicated that when we do more interesting things later. So I want you to keep in mind the way I'm describing it. It's how far away from 0 I am. But, you know, even just simply saying, oh, I make it positive is another way of doing it that works quite well for a while. Not forever, for a while. So let's look at an example of how we would use that in equations. Okay, so I could say, for example, the absolute value of negative 3 minus the absolute value of negative 8. What is that equal to? Equals what? I have no idea. Well, actually I do. Here, let me show you how to do it. And all we need to know when we're doing these kind of equations, when we're using absolute value functions, is we have one rule. We do inside the absolute value first. That's all you got to remember. That is the only rule, and as long as you do that, you're fine. So basically, let me see, I'm going to drop the absolute value here. So negative 3, the absolute value of negative 3 is 3. And then I'm subtracting the absolute value of negative 8, which is nothing more than 8. 3 minus 8, negative 5. Done. It's that simple. Let's go a little more complicated, and we'll look at negative 4 times negative 3 minus 5, the absolute value of negative 3 minus 5. So the first thing I do is I'm going to take care of everything on the inside. So it'll be negative 4 times the absolute value of negative 8, and that will be, sorry, that's equal to that, and this will be equal to negative 4, and now I drop the absolute value, 8. Negative 8, absolute value is 8, and that'll leave me with negative 32. See, it's pretty simple? Good. I am happy for you. Okay, so the next thing what I want to do here is look at what happens when we graph an absolute value function. So here what I'm wanting to look at is what happens when I am trying to graph the most simplest of absolute value functions. This is the most basic. y equals absolute value of x. And what you'll notice is that I've already set up a nice little table of values. But what I've done here is I've got one column is my x, and where you expect to see your y, I am looking at y equals the just x. I've removed the absolute value function, and there's a reason why I've done that, so bear with me. So with this case, I'm looking at 3, 2, right? Because y equals x, so whatever x is, y is. 1, 0, -1, -2, -3. And if I graphed it, well, I already have over here, I get a nice straight line, just running along. So everything looks great. But what happens if I got absolute value? And I'm sure you already can tell what's going to happen, but let's just bear with me and let's go through this slowly so we can see what it is I actually do to change the original function. So this is the base function here is y equals x. And what happens when it's actually now given an absolute value? Well, 3 is going to be changed to the absolute value of 3. Well, that's just 3. And 2, the absolute value of 2, 1. Absolute value of 0 is 0. 0 is 0 distance away from 0. But now we got -1, so now we've got a 1. Absolute value of -2 is 2. And absolute value of 3 is 3. So what happens? Well, it looks, if you think about it, from here on, it's the same. Nothing changed. And then from here, everything, let's say it flipped. It flipped. I don't know if I can, there we go, flipped. So what's that look like? Well, if it's the same on this side, that means my 1 is going to look just exactly the same. Nothing happens there. But then as soon as I look at the other side here, and by other side I mean from point where the y's are now in the negative. So whenever the y's are negative, of course, what's going to happen? Well, here's my -1, and it has become 1. -2 has become 2. -3 has become 3. So what's happened? Well, looks a little obvious what has happened. The negative part, negative y's are flipped. I flipped them into the positive, so it's almost like I just did that. I just flipped it up. So my function then is almost in 2 parts. One goes like that, and then suddenly at 0 it jumps back up. So it's a totally different line. Like if I had to describe this line versus this line, they'd be different ones. In fact, this is what we do. It's known, this is actually what's called, let me see, this is a piecewise function. In other words, it's in pieces. That's why they call it piecewise. It's in pieces. So normally, I don't necessarily have to say y equals, I can say that, but I can also write this as a piecewise function. In other words, I can write this, instead of doing this, I can actually say y equals, and then check it out, I just do this big piece like that, because I'm going to describe it twice. And I'm going to look at, now if it's 0, let's look it up at the table of values. If it's 0 or higher, it's the same as y equals x. So in other words, y equals x if what? If x is greater than or equal to 0. So from here on up, it's equal to x. X is equal to x. But then what happens if x is, well, where's the rest of it? That's from, well, all the negative parts. So if x is less than 0, in this case, after it's less than, at -1, -2, it's no longer that. What is it? Well, it's what would I be doing to this? I'd be multiplying it by -1 to get my 1. So actually it's -x. So when this is a piecewise function, this is how I write it down. I say, okay, so there's two parts to it. If it's positive x, if x is greater than or equal to 0, in other words, it's the exact same thing, but if it's a negative number, I have to multiply by -1, so it's negative x if x is less than 0. And that's exactly how you do it. Now, I'm going to do another video, so we're going to cut this one off now. The next video, what we're going to do is we're going to look at, say, a little more of a slightly more complicated function, but we're going to go through all the steps you need to go through to completely analyze one of these functions. And hopefully, so far, everything seems to make a lot of sense to you. So you're right and ready for tomorrow. But please look at the next video, and we'll go through that in just a little while. Okay, see you then.